All right, continuing the conversation in 3D printing and advanced manufacturing. My name is Adam Penna, and today we talk a bit more about metal 3D printing and how it's being used out there. And also today we have a special guest. It is Matt Tusz, and he is coming to us today from, where are you actually? You're all over the world when I talk to you.
Yeah, so right now in Merida, in Mexico,
Yeah.
I'm doing a little bit of a session to focus on a new project that we have kicking off, actually having to do with lean manufacturing and additive. So
Nice.
there's a little bit of an intense preparation before we actually kick off with the customer because, well, just I can get into that later, but yeah, hence I'm here for another 3 weeks.
Yeah.
And it's just a really great place to focus and disconnect from all the distractions to get work done.
I just wanted to say too, before we go too far on that, you mentioned one thing that I wanted to maybe clarify for people that were listening. When you're talking about lean manufacturing, can you explain a bit about what that is to the audience?
Yeah, actually, that's a really good point. So I think there's a lot, coming from manufacturing, there's a lot of people that understand the principle, the idea behind what are we doing with lean. I think a lot of times we kind of get this feedback of like, oh, that sounds really great, but we can't do that for our manufacturing. That doesn't apply for whatever reason. And the thing is, though, is it's not exactly a process, it's a mindset. So what you're in essence doing is you're basically analyzing what you can eliminate from your production that is a waste of time, that is a waste of money, and there's methodologies for doing that. So in traditional manufacturing, we have a lot of methodologies that have been developed, starting in the US in World War II. Then Japan took over that space very radically with Toyota, where they've really proved it out on a very large scale, to the point of you would order a car and only during the time that you placed that order did the car actually begin manufacture, and then 2 weeks later it was delivered. Right,
which is automotive
incredible.
industry, really. Yep.
Yeah. And then there was a big trend in the 90s for companies in the West to actually start implementing lean methods in order to, I think their biggest focus was like supply chains, right? Because we want to make our supply chains more robust, more lean, because there's a lot of waste. Otherwise, we're going to lose out to developing countries that can do everything cheaper.
Sure.
The thing is that these methods, they don't go away. It's not just for manufacturing. It can be used in a setting like a hospital. It can be used in a setting like a coffee shop, right? And to be honest, actually, some of my friends that work in the service industry, they can relate to lean better than people in additive. And there I was kind of like, okay, what's going on? Why are people in additive where, we're taking a product that takes, let's say, 12 months to manufacture with traditional casting, and now we're like, we can print this and we can get this to you in 2 weeks, right? Why is that not resonating with individuals that, you can actually make those additive operations lean? Well, a lot of times people are under the assumption that when it comes to additive, you can't implement lean. And that's not true. Yeah. There's a lot of things that you can do from a traditional lean perspective. And then we've actually developed specific methodologies for additive in order to make additive lean. And the results are quite surprising, like eye-opening, I would say.
Yeah, no, that's why I asked you that. That's awesome because it's a big part of manufacturing, and production, obviously, looking at how you can improve processes, and lean manufacturing really has kind of, encapsulated what we could do out there to make things better. But, when we're talking to a lot of people or to, at the additive crowd in general, 3D printing crowd, there is some kind of learning curve there as far as where that's happening. And it's because of all the different changes we've seen along the years and the progression with different printing technologies. But you deal with metal 3D printing a lot. That's your big focus. And I guess that's the overlapping background we have too, having worked for EOS for a period of time that kind of overlapped there before 2020. Yeah. So now you're doing a lot of the consulting side, and you get to work with these people out there in the industry to bring them to market, bring the products to market, and to kind of get a good look at what they can do or what they might be doing to improve their processes, like we're talking about. So with your history too, I mean, you obviously are education in aerospace mostly, correct? That's what those things. Yeah. So I mean, what brought you into wanting to do 3D printing and additive manufacturing? Really, that become your focus?
So the first time I actually encountered additive wasn't called additive; it was just called 3D printing. Yeah. It was an actual Stratus machine when I was doing undergrad research, and I wasn't the kind of person that was like, "Wow, this is, oh my gosh." It was actually more like, oh yeah, cool. Like I'm glad this is here. Like it was just so obvious that that there are tools that do this. Like it literally was like a 10-minute conversation of like, what can this do? And then they were like, just give me a SolidWorks model and we'll print it. And I was like, okay. And, you know, like 2 days later, I had a part. And at no moment, like being from that generation already that is like a digital native, at no moment did I have that question of like, what's the alternative? Right? Like it was just like, oh, okay, 3D printing exists. Yeah, of course it does. And and so that was in my undergrad. And then I didn't have any exposure to additive. And then when I was so I first did my bachelor's in aerospace engineering and another one in material science. And that's where I was actually using 3D printing for creating models for the wind tunnel. So it was like a really cool marriage of material science and aerospace. And then in grad school, I was actually focusing on manufacturing nanomaterials and composites with nanomaterials. And that like in between, I worked at NASA, and that's where another space where I was like using a little bit of 3D printing. And then when I was working at the Army Corps of Engineers, that was the first moment where I was like, hey, we need to look into this for composite manufacture. So specifically, we're working on self-healing composites. And the idea was to actually use 3D printing in order to manufacture the components with capillary cells so that like when the composite breaks, those capillary cells that were channels that were printed, they can deliver self-healing components for the composites. That never took off. But right afterwards, I actually went to Siemens in Germany. And that was my first like big exposure where I was actually working with Siemens like before, you know, the Siemens Energy department was really big, before Material Solutions was really prominent at Siemens. And that was the first moment where I really dipped my toes in additive and then actually was consulting internally to actually stress the point of like, we need to roll out educational programs. We need to focus on spreading this knowledge because we can't force people to use this. We have to give him this tool and give him this idea and they will adopt it, right? Because I can't make the part screening and the decisions in a manufacturing environment. But what I want is someone that's in the manufacturing space to say, this is necessary for this application. And the analogy that I've actually kind of discovered, like in terms of explaining that is like, imagine that you're living in a country, right? That has 1,000 manufacturers. And out of these 1,000 manufacturers, you're going to have about, and literally just no more manufacturers, right? Just 1,000 companies. And out of those 1,000 companies, about half of them are going to have people that have never seen additive and they don't care about additive. They've done things traditionally and they absolutely don't care about using additive because they've done things traditionally. And if they have a problem, they're going to redesign for the traditional methods. So right away, that is half the market is already eliminated because they don't know about it or they don't question, or they question it. Yeah. The other half might be open-minded. So that's 500 companies. Out of those 500 companies, maybe 10% are actually going to identify a problem that they can only solve with additive. And then out of those 10%, that's 50 companies, then they're going to look into additive and then say, okay, you know what, you're right, this is a good application. So it really isn't just like a top-down approach where someone in management says, hey, you need to use additive. Think about this now. You really need to have a bottom-up approach when these components are being designed, that people actually use this as a solution to their problems. And I think that this is part of the reason of why additive has had such a slow uptake in terms, in general, in terms of manufacturing.
Yeah, well, you're talking about a lot what's going on in that development side of additive manufacturing and where it's going on in industrial.
My apologies.
No, it's great because that's why I love talking to you, man. You've got a lot of background in that, and now looking at that though, I mean, you're focused on a technology that's mostly, obviously metal, but laser powder bed fusion is the technology, right, that you mostly work with. We'll talk about that a little bit and how that differs from other technologies out there and what it can do for 3D printing.
Yeah, so to take a step back, in all honesty, when it comes to the lean methods, it applies to plastic and metal in the same way. Right.
There you go. True.
The technical knowledge that we have is based on laser powder bed fusion and other metal processes. But when it comes to actually implementing lean methods, we don't mess with the tech, right? We try to understand the tech so that we can accommodate it in the lean tools, in the lean methodologies that we implement. But on the plastic side, it's identical. So for example, on the metal side, what you would have is you have a build platform and you can only build one layer of parts, generally speaking. And so what you would do is you would actually add or remove components or you would optimize the parameters. On the plastic side, you can't optimize the parameters, but you can actually increase the number of parts in a vertical direction, right? So in other words, when you're focusing on the cycle times or on the manufacturing or leveling approach of production, you would just do it in a different way. In metal, you would add more parts on the platform and reduce the parameter build times, while on the plastic side, you just add more in the Z height. So the consequences in the end the same. And in both, you're going to be able to utilize lean methodologies. So it doesn't really constrain the laser powered bed fusion, but there is, to your point, a very important reason why we focus on metal is because to this day, I don't know a single service bureau that's profitable.
Oh,
Right.
wow. Yeah.
And that's shocking.
Yeah.
And not because they're bad people, not because they don't know what they're doing. They absolutely know what they're doing, but they're being kind of torn in different directions. On one hand, we're in a manufacturing environment where cost is king, right? Nobody cares about additive. They care about their parts being cheaper, right? So you got to show that business case to the customer. On the other hand, when you have a large project that you would actually become profitable from, well, in that case, that's usually the case where an OEM is going to say, we're going to do this internally. Why would we give out this huge business that is a core competence of our manufacturing or of our product, right, to someone to manufacture for us? So it's a Goldilocks kind of issue. And so from that perspective, we identified that metal additive is extremely inefficient. So if you actually quantify the efficiency, it is less than 40% in serial production. If you're not doing serial production, it is around 20% efficient, right? So about 80% of the time on these systems is being wasted. And that's really, really hard to manage and really hard to optimize. So we've done that. We've optimized that and we increased those efficiencies. And to be honest, just knowing that your system is running at 40% or 20% efficiency is super important because that comes down to your pricing. And your pricing then escalates into what decisions are we going to make in terms of what business we're going to take and what business we're not going to take. Right. So all of these things are connected in additive. And this is, where, of course, a lot of people in additive, and I fully agree with this, always say additive is a special process. Right. Yes, for us, it is. For the end user, they don't care. Right. For us, we care. And we do have to respect those constraints. The end user absolutely doesn't care if it's a special process or not. They just want to get their parts. So we have to kind of separate that conversation, right? When you tell the customer additive is special and they go, is it cheaper? No, then don't talk to me about this. Right. And for us, it's like, yes, additive is a special process. We have to consider it in a special way. And so that's where we had to implement these lean methods in terms of, a special process of additive and special lean methods for additive.
Makes sense. Now, and I should also bring up, obviously, being your own company, they're the CEO at Magnitude. One of your biggest taglines, obviously, democratizing knowledge and doubling AM productivity. And you spoke about that a little bit, like you were just sharing about where that actually happens. Educating people, but also being productive with what you have and taking a look how you could do it, like with lean operation. So talk a little bit more about that. And maybe can you give us a little like insight into some of the, general projects you might be able to talk about that actually bring people into that kind of productivity out there?
Yeah, so that's a really good point. So, I mean, the democratizing knowledge is actually like our catchphrase, but it's actually kind of how we look at what are we going to do in the industry, right? So when we first started, we realized that there's a very large discrepancy between an OEM and someone that is opening a business that wants to run additive, right? So when you're opening a business to run additive, you don't have the resources of an OEM, but of course you have the speed of a small company. And these people are usually put into the position in terms of delivering a qualified process and developing parameters and, finding cheaper alternatives to the powder suppliers. And that gets really frustrating because they don't have the resources to tackle this. Right. And a lot of this knowledge, for better or worse, has been developed by OEMs, but it hasn't been shared. And so OEMs, obviously, they have to de-risk the technology and they have to, understand how this technology works so they can use it in their manufacturing. But then they give out this business to the small guy that, in the world that we live in right now, you could start a company for $20. You could have people doing your marketing remotely that you've never met in your life, accounting the same thing. And then, the actual guts of manufacturing something is now being done on a single printer and you can manufacture anything. Like, wow. I mean, really incredible kind of time that we live in. Of course, there are sacrifices with regards to that, right? And one of those things is when you now have this machine that can do anything, you have to figure out what are you going to focus on. And so that is already something that you do not want to spend 2-3 years working on, right? We can explain to you what is possible, what is not possible based on the technological limitations. And then the second thing is before you undertake an R&D project of developing a certain application, which we see a lot of people getting into that problem, is they develop an application and then they realize actually there is this one tiny problem, and it's actually a huge problem because that tiny problem means that they're not going to get the business, right? And so that tiny problem is actually a very big problem, right? It's not just 1% porosity increase on the downskin surface. That downskin surface is really hard to optimize, right? And this is why everybody thinks it's just a tiny problem, but it's actually very technically complex. So we deliver this knowledge in terms of what's going on in the process so that you're not stuck on these things, so that when you actually build a business model, you actually have the technical feasibility to deliver to that business model. So understanding the levers of how much it's going to take, how much it's going to cost, and then actually not wasting your resources on doing R&D that has been done with 30 customers that we've had. I think that's super important, right? And it's not about delivering IP from another customer, but it's about explaining to them the technical stuff of what is possible and what is not, and how you should actually tweak those levers, because there's a lot of them.
And you brought up a good point there too with IP. There's some things that you learn, that are from certain places or projects or things that have happened. But that's also a challenge there to kind of get over those things and then look across the board and say, okay, this is where I can now apply it over here and make that more successful, because we've been through these steps before. It's a different actual product, but there are steps that are similar that can be used that could speed things up or make it better this time around.
Absolutely. Yeah. I mean, just as a quick example is like, qualification, right? It's like when you qualify a process that is super complicated, and you really need to know a lot about the systems and about the process. Mm-hmm. But there's no like IP that is internal to a certain company, right? Mm-hmm. You have to qualify it. You have to know exactly how to execute that. And this is knowledge that you can gather from a lot of different places. And, you got to get this done, right? Like there's no aerospace manufacturer, for example, there's going to be like, you need to qualify this and we're not going to tell you anything, right? It's like, well, but you're shooting yourself in the foot. You need these guys as suppliers, right? Yeah. But then how to execute that and the methods and the operations that have to be undertaken, that is a lot of work. And you need to have aerospace knowledge, medical knowledge, material science knowledge. And yes, you can hire all those people, but that's going to cost you a lot more, and it's going to cost you a lot more time.
So intellectual property, though, and talking about qualification, you not only have the process qualification, the machine qualifications, the material qualifications, depending upon the application, of course. But you're looking at those things, and you could lock them in for a specific product for a customer. But then again, a new product with the same, machine, the same technology, you're going to have to optimize again, right? And so like any little change you have even to an existing product, you have to, is it requalify, or what happens when something has to change inside of qualified processes?
That's a really, really good question. The way I always give a clue to customers is, so number one, when you do qualification, it's actually divided into different stages, right? So a traditional way of looking at it is what's called FQ, IQ, OQ, PQ. So FQ is the factory qualification, which is you go to the factory and you go, show me how you guys are actually manufacturing this machine, and I'm going to sign off on, yes, everything was done correctly. IQ is the installation qualification. That's pretty much the same thing as the factory qualification. Then we get into the really big stuff, which is the OQ, which is the operation qualification. And that's the stuff where if you have a readout that says 2.5 volts, how do you know that it's correct? If you have the gas flow and it says it's 3 meters a second, how do you know it's 3 meters a second? You got to develop methodologies for verifying every one of these little things. And then we finally have, assuming that all of these things are running exactly how we want them, then we have the PQ, which is the performance qualification. The performance qualification is usually where you have your part. Now, from an engineering perspective, think about it abstractly, and this is the clue, right? Which is you want to do as much in the OQ as possible, and you want to do as little in the PQ as possible, because what that means is you've qualified the process as robustly as possible, and then every time you have a new application, you have less work to do. In the beginning, though, that doesn't make sense. In the beginning, I would argue, get as much stuff done in the PQ to just get the project running, because that's going to start paying your bills, right? And then as time progresses, if you have the same thing that is happening over and over and over again in your PQ, maybe we should move that into the OQ, because it clearly makes sense to have the entire process qualified in the OQ so that you don't have to repeat in the PQ every time. Right. So that's the way to look at it in terms of requalification or qualification in general, right? For a different application, how to segment that stuff in your mind as you go forward.
It's a great visual in my head. I was thinking about the process qualification side being, more of, like you were saying, getting it out there and learning from it to change what's going on prior. That might be called in the past the Microsoft model, when just push it all out there and see what it does, and then we'll get the feedback and change it from there. but
Well,
at the
they're
same
not
time,
contradictory, by the way.
but
That's a
no,
very
no,
good. That's a very good point. And this actually, you just transition to the next step, which is the operational excellence, right? Which
awesome.
is
Yeah.
you can do qualifications, you can do R&D with a lean mindset, and
Mm.
it goes to your exact point about the Microsoft thing. Man, Adam, you're just lobbing them. You're just
Yeah,
serving them up.
just there you go, man.
It's
Yeah.
it's absolutely it's a mindset of continuous improvement, and it's a mindset of do not plan too far out in the future, because by the time you get to those things, you're going
It's
to learn
awesome.
things that are going to completely change your plan, right?
Yeah.
And so make small increments and try to have a big vision, but make small increments in terms of your execution, right? It's
Mm.
better to waste time planning things out than actually executing them. Because if you're executing them, I mean, in manufacturing, that's, you know, a magnitude of order of magnitude of 1,000 more expensive than the time that you're going to sit together and plan things. So
Yeah.
you want to be lean, you want to be agile, and which is a slightly different concept from lean, by the way, but they're very aligned. And we're getting into, and this is actually from my work at Siemens, is what's called Legile, right? Lean and agile. And
Nice.
very few people do this in the world. And so, you know, we also like tackle traditional manufacturers when we do our work, because of the fact that these two things are complementary. Where does it make sense to use additive? Where does it make sense to use traditional? And how do we implement these methodologies and these mindsets? And so when you are talking about the Microsoft model, it's like, yeah, we could absolutely plan out this really fantastic qualification. It's going to cost us $500,000. But is that what the customer needs? And is that what the customer needs for 10 years from now? Right?
Right.
Is that like the need for this specific project, or is that a
Right.
general need? And this is where we'll work with the customer to actually tell them, like, listen, this little thing right here is going to cost you $200,000, and you're only going to do it once. Don't do it. Right?
Yeah,
Don't
the
waste your time on
economics
that.
of change, right? Everything is going to kind of change over time, and you don't want to set
Yeah.
yourself in stone and then not really be able to be agile
Not be
enough to
flexible.
adjust. Yeah, yeah.
Yeah.
One thing too, I wanted to back up just a little bit because you got some really good education coming out here for like what you've seen out there for prospects and customers getting started, barriers to entry. What do you see as the barriers to entry to get things kind of moving forward on the additive side? Yeah.
From which perspective?
Good point. Good point. I know that's a large thing. In my head, I was thinking of when you're working with the mid-range service provider kind of thing, where they're looking to incorporate having additive and they don't have it. Let's draw that barrier. They don't yet have it. What are some of those barriers of adopting it into their current operations?
So like a tier one supplier is what
Sure.
you're kind of aiming at?
Yeah.
So I would really break it down into like three different kinds of categories, right? There's first is like the small company, and it could literally be a single person with a machine, right? How do you get started? Then there's like the tier one suppliers where they have manufacturing and they just want to complement their offering. And then there's the OEMs, right? So when you look at like a tier one supplier, these are people that already have tremendous manufacturing knowledge.
Right.
So how do they motivate their team in order to get, into the additive manufacturing mindset? How do they also identify the potential with their customers of using additive, right? Because technically they have a huge Rolodex of customers that should be just calling them nonstop going, I want to use this 3D printer. Then they get the price of the part and they're like, forget it. The first thing there is the big barrier to entry for these kinds of organizations is their business model, because their business model is very ossified in terms of how they've done things for traditional manufacturing. And now you really need to have that one ambitious guy that goes into the customer and goes, I want to see your production. I've seen the things that you're ordering from us, but I want to understand how you're using these components, because we could offer you something much, much more significant than the parts that you have, right? And this is like, if anybody has ever read The Goal, it's a really great book about lean manufacturing. One thing that is a really, really beautiful piece of information from that thing is they talk about throughput. In other words, if you're making improvements, and I've actually seen one, by the way, I'm not going to shame the customer because I totally understand why they did it. But again, a large organization, right? Is like they were improving their jigs, and they got their jigs down to assembling a part in like 2-3 minutes rather than like the 30 minutes that it took before, because they have these printed jigs. The problem is that the output of the actual factory has not increased. So now there's an individual that is doing their work much faster, and it doesn't do anything. It doesn't move the needle at all in terms of the output of the factory. Why, right? Because that was not a bottleneck in their manufacturing, that individual was frustrated. That individual was overwhelmed with their work. And now we've made their lives easier. Absolutely, let's do that. But now, instead of spending 6 hours or 8 hours a day assembling this component, what they're doing is they're doing it in an hour, and then they're taking a coffee break for 6 hours, right? Or trying to keep busy because the output of the factory has not increased. And so we then look at this jig that we 3D printed, and let's say it's $1,000. Well, that's $1,000 that could have gone somewhere else in order to increase the output of the factory. So if you can imagine, let's say that we have a factory that has $1 million that is producing, and we can increase the output by $1 million. Well, then you don't care about the price of the additive component being $1,000, because technically that additive component can be $9,000, and it's still going to make a difference in your manufacturing, right? Because it's increased the output of what everybody's trying to do together. And so we got to take a step back from that traditional way of looking at components where this part costs 500. Why does it cost 1,000 on a printer? Because there's a lot of places that the printer can do some incredible things that the traditional manufacturing cannot do. And that is where it doesn't matter that the part is $1,000. And this is a very standard kind of lean approach towards understanding the manufacturing. So you can understand that when a traditional manufacturer, tier one supplier, gets an order for a part, and now they're going between traditional or additive, 500 and 1,000, nobody will ever take the $1,000 part. They're not crazy.
Yeah.
Right. And so when you, on the other hand, go, you know what, let me understand why you want me to manufacture this part. And then you go walk around that factory and you go, hold on a second, this part, not that helpful, right? It's 1,000 versus 500. But I noticed that there's a part right next to it that would actually increase the output of your entire factory by 20%. And your factory makes $1 million a month. I'm literally saving you 20% of $12 million every year.
Yeah.
I don't care that it's $1,000. So we got to look at it like at that mindset. And that's where I see like tier one suppliers, tier two suppliers being ossified in that traditional way. And they've been really optimized for that. And that's, I think, the big barrier to entry for tier one, tier two suppliers.
Yeah, there's a lot there, obviously, and a good kind of a ramp up for understanding where you might be going when you're dealing with somebody that could bring you there. That's the stuff that you don't look at because you get so micro focused when you're dealing with your one process or path or application that's so challenging. Taking a step back, and man, it's tough. I mean, it's obviously easier said than done, but there's steps to be taken out there. But getting everyone involved and buy-in for change is always difficult, no matter where it's at. And I even saw that, you look at the CAD world or, the CNC world, they're using a certain software their whole life, and they don't want to change to something, even though it could, increase production. Someone has to step in there and take a look at why, where, and how that could affect the company and where then you could add more value because of the time that you have. But they're got to be willing to do it, and that's that business case you're talking about, changing it, having the buy-in at the bigger level. But yeah, that's a lot of challenging stuff, man. So,
but listen, I mean, from one additive guy to another, you know this better than most. Like you walk into one of these factories, your brain just clicks in that way. You exactly see what is feasible very quickly. You don't have to translate that knowledge for somebody. You just have to go and just be like, guys, just give me one chance. Just let me walk into your factory and just give me one day. I don't need to get the entire team. I will literally identify 15 things that we can manufacture for you and save you millions of dollars after one day. Yeah. I mean, it really is that simple, but there has to be that trust. So I think we have to leverage that trust that we already have with our customers. And then just, as opposed to spending a lot of money on manufacturing demo parts, I think if they were to do that legwork and actually show up at the factory and just screen what they're doing in operations. We do this. This is super easy. We do have a methodology in order to quantify exactly what the savings are, right? But after a single day, we can already tell you down to 10% of how much money you're actually going to save by implementing a single additive component. Which is, it's there are ways. And again, like I am in no way saying that this is our IP. Like if anybody wants to contact us and get these pointers, I will be more than happy because again, we're democratizing this knowledge because we really believe in additive. And
Okay,
there's
well, you mentioned it. Why don't you go ahead and tell
pillars.
people where they can contact you if they need to there? Where could people find this information?
LinkedIn, I think, is fantastic.
Yeah,
Email, I can leave my contact details at the end of this, or I don't know how you
sure.
guys,
Yeah, we'll
how
put it
you
in
how
the
you prefer
description
this.
also to make sure people can get a hold of you. Check the
Perfect.
description and definitely have
I'll
it and
share
all
with
there.
everybody my WhatsApp so they can spam me.
Uh-oh.
And yeah, but honestly, LinkedIn is very easily accessible, and I read. I don't have like somebody that does it for me. Like I read all of my messages personally. Yeah, and then email and phone. And of course,
Good,
we're
good
always
deal.
at the
Good.
conferences. So
Well, yeah, that's true. That's true. But I want to, expand it to the people that are out there that maybe be listening and want to contact you because there's a lot of good information inside of here. So we'll make sure that's in the description. But to jump back, because I wanted to ask just a kind of like another question to what you were talking about there. It's more than just part selection, right? I mean, that's a big part of it. Like you were talking about going into the shop there and taking a look around and seeing what can be done. But you look through part catalogs of what's happening there as far as what they might want to look at, looking at assemblies or, and seeing how you could maybe print all that in one print instead of doing all those different processes. So talk about those things that you see. What out there that kind of happens when you're looking at all this starts to reduce and also make people aware of where they can go using additive.
Yeah. So, I mean, I think a really great example is, and this ties integrally into this operational excellence lean manufacturing principle, right?
Sure.
So if you see someone that is spending an exorbitant amount of time working on something, right, in your manufacturing environment, and you go, you know what? If you would just have some kind of a jig, right, to improve these operations. Then all of a sudden he would be able to do 5 times as many components.
Sure.
Then you go, okay, well, follow-up question. And this is a funny thing from lean, right? Because when we look at lean, we can look at it from a one single process step perspective and the whole picture. And so what we would do is we wouldn't look at a part catalog. What we would actually do is we would actually look at the costs. We would take a look at how many things in a manufacturing assembly line are being expedited, right? And then ask ourselves,
okay.
Why is that happening? Why are these components being expedited? Because you're ordering in batches, right? You're ordering 1,000 pieces, you're ordering 500 pieces, and like let's say the lead time is 12 months. And so you go, well, what if we were to like actually get this part in these critical times where you're waiting for a 5-month lead time? What if we were to just manufacture a couple of them in additive? How would that reduce your lead time? How would that increase your throughput? And how would that reduce your work in progress? And that's a very interesting hypothetical question, right? Because we're identifying a component that takes a long time to deliver. And that doesn't mean, and this is where people usually jump, the psychic leap in additive is we can print this and you'll get it in 2 weeks. That doesn't make sense. You're still not going to compete with a component that you're ordering 1,000 of. You know that, right? So the question is how can we just get 20 of them on the shop floor? Because if we get those 20, then that 5-month lead time is now a 3-month lead time, right? So now you're not ordering every 5 months 1,000 components. You're going to order every 3 months 800 components. And that's where the economics already start playing in, because now that we have these smaller batches, well, we have less inventory. We have a shorter lead time, which automatically means that everything else there's less of, right? Every other component. So you then don't just look at that one component that you've been focusing on, but you actually look at all the components that you have in your inventory, and you have less of them. And now that's a saving from additive. And all we did was we manufactured 20 of a single part. So that's a really cool way of analyzing it. And this really is back of the envelope, simple calculation. So you got to take a look at things that have a long lead time, things that have large inventory. And those are the things that unlock output. Sorry, go ahead.
No, I was sorry. I just wanted to back up what you said earlier too. I mean, and these are things that are not only metal, 3D printing. It's polymer 3D printing processes of things you could use out there, knowledge for ramping up and understanding things. It's more of an overall arching way of looking at 3D printing. There, you're talking about not just metal. Yeah. But I know that is your focus, and you do really great in it. There's a lot of great stuff that happens. I'm excited. I do get excited about what's happening in metal AM just because of the precision side. I mean, you look at some of those applications, and my background was in a lot into metrology and CAD and that side of it. And when I look at what can be done now in the inside of these precision metal parts with a laser and powder bed, it's exciting, things that are going out in outer space that are going to go further, faster, longer because a lot of these cooling channels and things that are in the walls of, it's amazing. It really is. And then you look at anything on the medical side and what's going on with metal 3D printing. You couldn't do a lot of the osseo integration and things like that, where you're actually printing somebody's bone structure right inside of them. You can't fathom that if you're looking at the outside and going, oh my gosh, that's how precise this is. Now you talked about constraints too. Of course, everything has constraints, limited in size, materials, what can be done, but still that precision of what we're doing inside the space we have this time in 3D printing is really, really stepping up. And it's exciting to see those applications as they develop because it's real. Yeah. So,
yeah,
cool.
I mean, on the medical side, I've been now in the industry for 11 years.
Yeah.
I've actually been involved in to an extent with the first FDA certifications, and I was watching this go on, and that was really fascinating because the companies worked very closely with the FDA to help them understand how the process is working. And after those first certifications happened, I mean, the industry has exploded, and quite frankly, in now already, I don't see how we're ever going to live without 3D printing when it comes to medical applications, because the volume of components, the complexity of components, how we do things in additive versus how they were done traditionally, there's no going back. There's really no going back. And there is a very serious concern from the OEM side, which is how are you going to deliver the capacity with additive for our needs? And that's a very interesting question. That's a question that has come up over time again in the last 10 years. And that is slowly being answered with many different ways. But it's interesting how on that side, people are going, we need more. And then how in certain industries, it's we can't justify having 5 machines, because it's a completely different world. It's a completely different struggle. But medical applications, to your point, I mean, incredible, really incredible stuff. Some of the manufacturers out there, especially in the States, are they're doing some really incredible stuff. When you see their operations, I get excited because I love working with them. But they do some really incredible stuff, and the scale of it is impressive. It's really, really impressive in terms of the volume of products. Around 500,000 a year of parts from one of these manufacturers.
Yeah,
in additive.
Well, exactly, metal additive. Another thing too, talking about the other side of democratizing knowledge in general, and we talked a little bit about it in the beginning, where we come from and this schooling and the way things are handed back to people, the next generation that's coming up. What do you think? What do you think you've seen are some of the new stuff? I know AI is a big tool out there that's attracting a lot of attention. There's some of it that can be used, obviously, and it is being used on the additive side, and it will continue to grow. But those are the little things that grab attention of the younger generation coming in and in the workforce. So how do I guess you're talking a lot about how you actually are opening the knowledge for everybody on how these things actually happen, but there's a lot of people that don't know that stuff, or it's going to take a while to get to it. So what would you say might be able to help, looking back, if you were a middle schooler or high schooler and you're trying to understand a little bit more about it, what do you think are some tools that might work nowadays for that?
Tools for educating, you're saying?
Yes,
honestly, hands-on. I think that there's a lot of these manufacturers, they have they need people, right? When we're talking about AI or when we're talking about the lean stuff, people are concerned that they're going to lose their jobs. And that's tragedy of the commons kind of thing, or Luddite fallacy, where that's absolutely not true. We're right now not able to justify using the technology financially speaking, right? Because we're doing things inefficiently. If you start doing things efficiently, the amount of jobs is going to be actually even more than there are now. It's going to explode even further. And that's, I think, a really interesting point. Maybe in 30 years from now, yes, people would start losing jobs. Maybe. But that's such a ridiculous projection, right? Can you imagine using smartphones 30 years ago?
Right. And a lot of the industrial age and everything else, all the changes, it's always been, there's a scare that, it's going to lose this, and then it just fills in with all the new, jobs and operations that open up for people to do that they didn't know that were going to be there, because you couldn't see that because it hasn't been out in the population for too long. Yeah.
Let me give you 2 examples. There are more horses now in the world than there were in the 1920s before the car took
Wow.
off, right?
Wow.
How
Yeah.
is that
Yeah.
possible?
Right.
There
Yeah.
are, like, when the printer came out, people print more now than they did when there was, when there wasn't any electronic format of things, right? People
Yeah.
print more. So like, you think that it's going to destroy it, and actually it just becomes cheaper and people just use it more casually.
Yeah.
And it's the same thing in additive, which is that if every organization was to have the mindset that additive empowers, oh my gosh, like we would have a really big recycling concern that we should talk about at that point, right? Which
Yeah.
we'll get to, and that will actually be a part of the solution. But when it comes to educating people on utilizing the technology, I mean, every single manufacturer that I know is more than happy to actually have somebody come and do an internship, where there
Great
is a
point.
lot of
Yeah.
work that you really, really got to start off from the basics. And there's no, book that's going to give you that hands-on experience. Having said that, I am in no way saying that you're going to just absorb that knowledge by just being there, right? So there's a lot that you can do on your own with your high school, experience, where you sit down in a high school and they do have printers, they do have workshops in order to actually make something cool for yourself. And I think the interesting part about it is that, like, just like in a manufacturing environment, when you think about manufacturing, you go, right, we need A, B, C, D, E. Then when you actually visualize in your mind of like how it's going to run, you're going to be like, wow, we needed 20 more things that I didn't think about, because you actually think about the individual steps. So going and doing a project, like actually thinking about, I want to manufacture something, and then actually executing that, you're going to learn a lot more than anybody who's just going to be, learning the theory. And so you need to have this complement between learning the theory, which is extremely important. And the analogy that comes to mind is like a doctor nurse, right? A nurse can do a lot of things that a doctor can't. But when something goes wrong, the nurse is going to be like, I have no idea what's going on. And then the doctor comes in, right? Because he has that educational background to solve these problems. And you see this in additive. You see people that don't have that education, and then they struggle when a problem comes up. On the other hand, they're absolutely indispensable when it comes to actually the hands-on stuff, because they're pragmatic people. So there is always this battle between theory and practice, and we need both. There's no illusion.
Both sides are important. That's a great point. Yeah.
And so when you're in high school, I mean, absolutely, you can do an internship. If you're 16, you can already get a job in the US working for any of these people, to be doing these things on the side, to be like on the metal side, you could be learning how to do wire EDM. You could be learning how to, depowder components in plastic, or how to shot peen the parts. And, that is not a job that is like a low hanging fruit. I've done all of those things. I've done all of those things to learn the process and to appreciate what people have to go through. And I still do it sometimes. Like sometimes we're working with a customer, and, lean is like, you actually get involved in how do we turn these things around. And so you actually work with the people, work on step by step with them to talk about, what are you doing here and how can we improve it? Help me understand. I'm going to do it myself. So all of these hands-on things are super helpful. And when you then have that on your resume, people won't stop calling you.
Yeah, that's true. Get in there and get a lot of hands-on experience. There's even the manufacturing jobs in general, like shot painting, you use on all parts. It doesn't have to be 3D printing. There's all these different processes that are part of the whole production line of AM that you can kind of get your hands on and dig in and really learn what's going on. So all great steps to figure it out and kind of get involved. But yeah, it's difficult to see that when you're coming up to schooling and stuff like that, to be exposed to those kind of things. So get involved with a lot of localized programs and stuff like that, for sure.
I was about to say there's like the national programs, and there's local programs, and the local programs I think is the best way to get started on this. And obviously, like, not everybody in the local programs can have all this knowledge, right? That you and I are exposed to all the time.
Sure.
So if they want to reach out, like, I would be more than happy to get them in touch with individuals from universities. I know some people that are actively looking for individuals that are passionate about this for university work. I know in Kentucky, Ben is actually has 100 students that he's working with, which is really cool. In MIT right now, they're building a whole new program from the ground up, right? And you don't have to be an MIT student to be a part of that program, right? So I know obviously it's not like to everybody, hey, you're from an inner city neighborhood, apply to MIT, right? Not the easiest to get into. but they're trying to actually open this up to everybody. And so
Sure.
whoever you are, you don't need to have straight A's. Now, obviously, straight A's are great, by the way. If you have straight A's, absolutely apply. If you don't have straight A's, don't be discouraged, is the point. Because your initiative is, that's actually one thing that, like, I feel every time I run into somebody that is interested, I really don't care. Like, if they're passionate about it, I don't care what grades they have. Like, I'm just going to take that passion and mold it into something beautiful. When you're kind of dragging and pushing someone, take a horse to water, you can't make him drink kind of analogy. Like, it's super frustrating because, they got to be open-minded. They got to be excited about doing this stuff. And that's super important, right?
That's a great point. That's a great point. I've worked with a lot of people too, even on the, mentoring or working with younger students and things like that. Some just don't want to do that. They're just not into it. You can't force them, and then at least show them or be able to, be around different examples of things that might spur their interest. But if somebody doesn't really have the drive or interest to do it, there's nothing you can do. You just got to have, there's something else that's better for them to get involved with. Different things for different people, that's for sure. I mean, it's been great talking to you, man. I know we went over a lot, but we didn't talk about like the outlook and the growth that's going on. What are your predictions for the future of Metal AM and what you see happening right now?
I'm very skeptical, and that's why I'm in the industry.
No,
I'm like, I don't think my opinion in this case is as valid as other people's because I've drank the Kool-Aid, right? Like, I believe in this. I personally think that, like when we work on lean projects, when we double the output of the factory, it gets a little bit scary because it's kind of like, oh, we can tackle all of these things that we couldn't before, right? And so quite frankly, like, my imagination is probably limited when it comes to this in terms of what is the potential. Now, will people actually execute on that potential? That's where, it's a lot of hard work that they got to do in order to get to that point. And, any founder of a company, it's like preaching to the choir, right? It's like, I won't even say that. I feel like that's just like talking down to them. I know they're busting their butt. I think that the industry is, no matter what, going to continue growing. I think it depends on who you're speaking with. I think for the machine manufacturers, that's going to be more difficult because we tackled, 80% of the problem by just creating the printers. And then there's the Pareto principle of like the 20% of things that like solve the challenges of individual applications. Machine manufacturers have to do a tremendous amount of work to deliver those solutions. And for each one of those applications, it's a different solution and it's all encompassed in one machine. That's super complicated, right? When it comes to the powder suppliers, I think they have a really, really good future, or, raw material suppliers. When it comes to being employed in the industry, I think it's incredible. It's ridiculous right now. Like, people that have very little experience are getting 6-figure salaries, less than 2 years, and they're getting 6-figure salaries in the States. In Europe, salaries are a little bit lower. I would say about a third of what we make in the States, but it's still very, very good for Europe because, cost of living is different and everything. So if you want to get a job in additive, incredible. If you want to sell machines, good luck to you. If you want to sell material, absolutely wow. If you want to utilize the technology, like right now, this is a moment where any manufacturer that wants to utilize the technology, there's no risk. People understand now what is possible, what is not possible, and what is going to take a couple months to deliver. So right now, it is like the people that are going to be utilizing this technology, they're really going to make a killing. Especially with reshoring and
there's so much to go. I mean, we're just kind of tip of the iceberg right now with what's happening, and of course, another tool in the toolbox. There's a lot of things that you learn along the way, and a lot of things that can't be done. But for what we talked about inside of those brackets, it's exciting for sure. Looking forward to a lot more, man. Well,
personally, 8 years ago, I remember being in a Formula One team, and they were going, "Is this 3D printing thing for real?" I think like the entire Formula One car is 3D printed right now. But legitimately 8 years ago, they were going, I don't know. I don't think so. Nobody has that conversation anymore. Like, let's not forget that. Let's be positive, right? Like, I know that the industry has gone through some tumultuous stuff right now, but that's more of a perception. It's not like, 90% of the industry has been laid off, for starters, right? But we hear those things and it really affects us. But keep in mind that 8 years ago, people were going, I don't think this is actually going to manufacture a final component.
Right.
nobody's gonna, like, if you were to say that right now, you'd be like, what time period are you living in? You know, like,
Yes,
it's
it
been
was
proven.
accepted for prototype, but really not
Yeah.
thought of at all for production, you know, and
Yeah.
now it is. It's proven
And
itself in a
we're
lot
taking
of
that for
different
granted
cases.
already, right? Like,
Yeah.
that was, you know, that was just 8 years ago.
Yeah.
So yeah, so and now it's like the real hard work of like, okay, now we know, now what do we do with it, right? And that's a lot of work for individuals, and so we're more than happy to help.
Awesome. Well, Matt, it's been wonderful talking to you, man. Let's definitely keep the conversation going. And if there's anything else you'd like to share while we have you here, are you good, or something else
Honestly,
didn't
Adam,
cover there? We covered
I
a
just
lot,
love
dude.
that you do this. I love that you do this. Like, you're always a fun guy to chat with, and you're, I don't know, just a great conversationalist. So it's just really enjoyable. So thank you for having me. Like, this is
Yeah, we've been planning it for a while, so it's great to do it, man. We'll have to get something going on a regular schedule here, so we can check in with each other and talk about what's been happening. But
would love to.
Well, awesome, my friend.
I think
We'll
there's a lot to talk about, by the way, about the difference between the North America and Europe. Super fascinating, because working in both of these continents right now, the outlook is completely different. And it's really, really fascinating. We'll both go down the differences.
Yeah, and that's kind of where I came in, obviously, too, with the growth that was expected in North America, you know, back starting in what was it, the end of or beginning of 2015, looking at, you know, additive and metal for the first time at that time, and seeing the different growth that's happened since then and the expectations. It's just, it's a wild ride. They call it the Wild Wild West. I've heard it called a potpourri of different things happening out there, but it's all been it's been wild to see them actually come to life. You know, people telling you that you're in something that's like an R&D tool, like we talked about, that actually becomes a reality of a production tool, you know. And from the old manufacturing world, obviously, there's a lot of different things that incorporate, like you're talking about with lean manufacturing, that have been brought over to the additive side. And that's what we've seen more of the crossover, I think, in the last few years of being accepted more into regular manufacturing, and another process that you could use, another option that gives you a different way of approaching a design, and see what you could do with it. You know, that's the challenge right now, is people out there is understanding what they could do with it, and you're a big help with that out there. So thanks a lot for doing what you do also.
Yeah. Thank you for your time, Adam.
All right, buddy. We'll talk to you soon, Matt. Thanks.
All right. I'll see you soon. Bye.